first of the service bulletins that we'll look at is bulletin number 114. The subject is automatic valve lubrication on all R680 engines so equipped. The engine feeds its oil from the oil pump, which is back in the accessory case, through a passage in the very bottom of the power case through to the nose case. When it gets to the nose case, it splits in two. One channel goes up and feeds the master rod, link rods, and then sprays around on the inside of the engine to lubricate cylinder walls and pistons and all that. The other passage comes up into the nose case, and there is an annular groove that is machined in the nose case that we'll look at on the bench in a little bit. But that annular groove, it feeds through a little oil jet. And that oil jet is located behind a pipe plug that is buried down deep in here. And I'll show you that close up in just a minute because it's important to know about this. That oil jet is the subject of this service bulletin. Let me read this. Having had several complaints of the valve gear metering jet plugging up, it has been found that when the QNO is not turned daily, or the metering jet has not been cleaned every 25 hours, particles of carbon circulating through the oil system have a tendency to plug the 30 thousandths inch metering jet, stopping the oil flow to the rocker arms. So the little jet in there was originally 030. So 30 thousandths in diameter, and what they found was that just little pieces of carbon or gasket material or anything that was floating around in the oil would be enough to plug up that little metering jet. So this service bulletin has us modifying that metering jet and opening it up to 58 thousandths. So we're going to drill that thing out and enlarge it to 58 thousandths. Now unfortunately that job cannot be done with the nose case on the engine because metal will get into the inside of the engine. So the nose case has to come off for that to happen. So what happens if that oil jet becomes plugged? The oil runs around in that annular channel as it comes through the jet, and then it feeds out through the tappets into the push rods and out to the rocker arms. Now all the rocker arms that are below the center line of the engine are going to wind up with oil anyway, just because the oil drains down. But all the rocker arms that are above the center line of the engine depend on that oil jet and the pressure oil. It's low pressure oil, but it's still pressure oil that's being fed up through the rocker arms to lubricate all of the rocker arms. We had an engine come in a few years ago that it had 800 or 900 hours on it, and one of the things that we noticed was when we pulled the nose case off that jet was plugged up solid. So we went to the number one cylinder and looked. In the number one cylinder rocker box, there was a hole in the side of the rocker box where the rocker arm bearings had failed for lack of lubrication. The rocker arm, every time the push rod actuated the rocker arm, rather than going up and down, it was going sideways, and it had worn a hole right through the side of the rocker box. So that was a rather extreme case, but still, if the rocker arms do not have lubrication, the bearings will go away pretty quickly, and also the valves will not receive lubrication either, so you'll wind up with stuck valves before very long. So the service bulletin has us enlarging that hole from 031 to 058. The military took it a little step further, and in technical order 02-15AB-11, they had us enlarging the hole from 58 thousandths to 81 thousandths. So they wanted it even larger, and it seems to work fine at 81 thousandths as well. They found that even the 58 thousandths hole would sometimes get blocked by carbon particles, and it would shut the oil off. So let's look at this on the bench, and it'll make a little more sense from where I can show you the inside of the nose case and that annular ring and the jet from inside. Alright, this is a 300 horsepower nose case, and you remember how I told you that the oil feeds through the power case and then down into the nose case. This is that port where the oil feeds into the nose case, and we'll show you how that gets to the crankshaft here in a second. This is the annular ring that traps the oil. This ring is just a few thousandths of an inch larger in diameter than the inside diameter here. So you have to heat the nose case, then this ring drops in, and when the nose case cools, it shrinks around this, and that's what traps the oil in this annular ring. So let's take a close-up look at this. Okay, here we are close up, and what I'm going to do is I'm going to rotate this thing 180 degrees so that we can see things a little bit better. This is that port that I was showing you. So the oil passes down through the power case from the accessory case and to this port. Then the oil feeds down through this port, picks it up through this port, and brings it over here to the crankshaft. There is a set of transfer rings on the 300 or a transfer sleeve on the 225 that then transfers the oil into the crankshaft, and it goes back into the crank and feeds the master rod, the knuckle pins, and then sprays around on the inside to lubricate the cylinders. So that's one passage. The other passage, there is a Y right in here, and this is the other passage. Oil also comes up through this, and this is our little jet that we've been talking about in the service bulletin. This particular nose case has been modified to 058, so this had the 58 thousandths modification done to it, but not the later 81 thousandths modification. But you can see how that the oil passes into this port, then through this little jet. It reduces the pressure in that little jet, and it fills up our cavity here. And then each of these is a passage that goes to the corresponding tappet below it. So that's how the oil gets into the tappets and then out through the tappets, through the push rods, and into the rocker arms to lubricate the upper end. But it's this little jet that the service bulletin is involved with, and you can see why it's not possible to do this on the airplane. You have to pull the nose case off in order to do this. If you drilled it from the outside, you could do that, but you would wind up with metal shavings in this chamber, which would then be fed out into the push rods and would probably stop up a push rod. We have quite a number of service bulletins in our little collection, and some of the service bulletins are only informational in nature. Probably don't carry as much weight as some of the other service bulletins. This one that we're going to read now is, in my opinion, the most important service bulletin that Lycoming issued for the R680s. So I would like for you to read along with me on this one. This is Service Bulletin number 126, dated April the 1st, 1946. The subject is the installation of lock plate and replacement of link pin clip screw. Models affected, all model R680 engines. To eliminate the possibility of lock wire failure on the master rod link pin clip screw, a new lock plate for safetying the link pin clip screw has been designed. The following parts are required for each engine to accomplish this change. 4 of a part number 40286 lock, 4 of a 559G screw. The new link pin clip screw lock and the new hex head link pin clip screw should be installed at engine overhaul. Tighten the link pin clip screw to 75 inch-pounds torque and lock by bending the lock plate up against the two sides of the link pin screw as shown. And then it has a little diagram that shows that. Well, I took a photo that I think will make this a little bit clearer. And in this photo, you'll see these cap screws on the right-hand side with safety wire. That's the old style. Now on the other side of the link rod, or master rod assembly, on the left side are the 40286 lock clips and the 559G bolts, which is actually an AN4-5A bolt. And so it's the old style on the right, the new style on the left. And what you'll notice is that each pair of knuckle pins are locked by one cap screw and then safetied to the next pair of link rods on the master rod assembly. Now what the experience that Lycoming began to have, and this didn't happen a lot during the early days because the engines just didn't rack up enough hours to really begin to have the kind of failures that they began to see during World War II. But during World War II, that safety wire began to vibrate in two. When the safety wire broke, then the cap screws would back out. As soon as the cap screws backed out, the knuckle pins could begin to back out. And let me show you a little bit closer view of this, and it'll make a little more sense. You can see a little closer view of the cap screws with the safety wire. And once those knuckle pins began to back out, the engine's days were numbered, as they say. I'd like to show you a picture of the aftermath of a guy who didn't replace those. This is what was left of his engine. He sent this engine into us after having had probably one of the most dramatic, catastrophic failures that I'd ever seen. He was flying along in his Stearman. Everything was fine. Nice day, smooth air, all that kind of stuff. All of a sudden, there was an explosion up front, and things got very quiet. He looked up there and realized that he no longer had a propeller. And what had happened was his knuckle pin, the safety wire had broken, the screws had come out, and the knuckle pins began to back out. As soon as the knuckle pins backed out far enough that the crankshaft counterweights hit the knuckle pins as the counterweights came around, it grabbed that master rod and in one motion wadded the entire master rod up on one side of the case. The engine stopped so suddenly that the crankshaft actually twisted about 30 degrees before it broke the crankshaft right ahead of the thrust bearing, and the crankshaft and the propeller went sailing off into a bean field. And that's when things got really, really quiet. Fortunately, he was able to land the airplane safely in that same bean field and was able to walk away from that. But it absolutely destroyed the inside of that engine. There just wasn't anything left. And we were able to pull the carburetor off of it. We were able to save a few things in the accessory case. I think the prop governor was overhaulable. Other than that, there wasn't anything left of that engine. And so it was a horrible, catastrophic failure. And since that time, we have had 3 or 4 other engines come in with the safety wire broken. Customers didn't know about it. They just had a feeling that it was time to overhaul their engine. And so they sent their engine into us. The safety wire was broken, the screws were laying in the bottom of the engine, and the knuckle pins had begun to back out. So it was only a very short time before those were going to be catastrophic failures as well. My feeling is that this should not be a service bulletin. This should be an airworthiness directive. It's such a serious issue with the Lycoming engines that if they're still running the old safety wire, they should have that, there should be an AD that would require at least an inspection. So how do you find out if your engine, the one that you've got on your trusty steed, has safety wire in it or the later lock pin clips? There are a couple of ways. If there's an entry in your logbook that says that service bulletin number 126 was complied with, then you know that you have nothing to worry about. If you have an engine that we overhauled in the last 30 years, which is how long we've been in this, all the Lycoming engines that we have ever overhauled have the late style lock pin clips in them. The other way to tell is by removing a cylinder. And so just pick the easiest cylinder to get to on your engine and pull a cylinder. You can look in there and see very easily whether this service bulletin has been complied with. If it has not been complied with, it will require the propeller coming off, the nose case coming off, the front bearing plate coming out, and you can get to the knuckle pins that way. It's a lot of work. It's not as much work as a complete teardown on the engine. Can be done in a couple of days' work, but it is cheap insurance. This is an absolutely serious issue that every Lycoming engine should be upgraded with the locks rather than the safety wire.